Hey guys, welcome to lesson 2.3. We're going to talk about some properties that graphs of functions have. So first off, we need to talk about what is and what is not a function when you're looking at a graph. So you probably learned in Algebra 1, maybe even Algebra 2, about what's called the vertical line test. If you can draw a vertical line and never cross your graph in more than one spot, then that is a function. So this right here, we've got a graph. This is a parabola. You're going to know that. And everywhere you draw a vertical line, you're always going to cross your graph in just one unique spot. So that is a function. This is a cube graph. That is also a function. Everywhere you draw a vertical line, you're only going to hit your graph once. This is a parabola, but it's a horizontal parabola. And you can obviously see that if you draw a vertical line, you're going to make contact in two different points. And what that means is that one x value has two different y values associated with it. Sometimes when x equals 1, the function equals 1, and sometimes it equals -1. And that's not a function. Okay, you need to have one unique y value to any x value that you have. So this is not a function. But these two are. And if you look at the directions, it says if it is, then it asks for the domain and the range. Okay, so the domain, remember, those are your x's. What x's are you seeing in the graph? Well, this graph is going, there's two ways to do this. One is just to look at the function I gave you. If you don't see a fraction and you don't see a radical, then you know it has to be all real numbers. But also those arrows and the fact that, yes, the arrows are going up, but they're also getting wider and wider and wider and wider to negative and positive infinity. So the domain would be all real numbers, or you could say it's everything from negative infinity to positive infinity. Okay, that'd be my domain. The range, well, those are your y's. What y values are being used in the graph? Well, there's nothing down here. This is the lowest point of the graph, so that's 0, and then it goes up to infinity. So you could say y greater than or equal to 0, or you could say from 0 to infinity, including the 0, but don't ever include the infinity. Okay? How about B? The domain is, well, again, no radicals and no fractions means it's all real numbers, but this graph with the arrow going towards the right, and this part it's going towards the left, that also tells us that every single x value is being used, and the range is everything from negative infinity up through positive infinity with no breaks or gaps or anything, so that's also all real numbers. Okay, so that's identifying whether or not you have a function. Now, next thing we're going to talk about, this is going to be pretty intuitive, and it's just the fact that you can have parts of a function where the graph is increasing. So as you move from left to right, your function values are going up. You could have intervals of the graph where the graph is decreasing. So again, as you're moving from left to right, the function values are dropping on you. And then you can have parts of your graph where it's constant. Okay, it's just a flat line. It's horizontal. The only tricky thing on this is how to write it. Okay, so if you look at this graph, as you go from here to here, the graph's going up. So you're all going to look at that and say, okay, the graph is increasing. As I go from left to right, my graph's going up. Okay, well, here's how you write it. A function is increasing on an open interval. So first off, open means we're going to be using parentheses for all of these. You'll never use a bracket on these. And it's an interval saying from what x value to what x value is this occurring. So from -3 to -2, the graph is going up. So it starts going up at -3, and then it stops at -2. So that is an interval. This is an x value, and this is an x value. It looks like a point. Because we're using parentheses, it kind of looks like the point -3, 2. But in the context of the problem, you can tell that we're not talking about a point, we're talking about an interval. Okay? So list the interval, and I even have from x1 to x2. So as your x's are getting bigger, the graph's going up. Now, you can probably look right here and say that, okay, well, this little segment of our function is constant. It just stays at 1 the whole time. So what x values is that occurring at? From -2 to 0. So that's how we write our interval, from -2 to 0. Then you see the graph goes up again. So there's another interval where the graph is increasing. Again, from what x value to what x value? From 0 to 2. And then you'll see the graph is decreasing. From what x value to what x value? Now, a lot of people get tricked by this because they see the arrow going down and their brain thinks like negative infinity. Well, that'd be the y value. It's going down because it's decreasing. But what is the x value? Your x values are actually getting bigger. This graph is going to the right, so it's everything from 2 to infinity, and again, parentheses on both sides. Okay? So those are intervals where your graph is increasing, decreasing, and constant. All right. The next thing we're going to look at are what are called local minimums and local maximums. Again, this is going to be fairly intuitive. It's just how do you answer questions about these. A local maximum occurs when you have a high point in the graph. Local means it doesn't have to be the overall maximum value of the graph. This graph could go down, could turn back around, and could be going to infinity. So there is no maximum. A local maximum just means there is an interval that I could kind of, block off, and I could say that this is a high point of my graph. Okay? It is locally the highest point. It's a maximum. To have a maximum, you have to have low points on either side. So if your graph goes up and just stops, that is not a local maximum. Okay? So it's got to go up, and then it's got to come back down. The question is, how do you answer questions about this? So you are going to be asked questions like, at what x value is there a local maximum? And you will simply say that number right there. So what is the x value? So where is there a local maximum? In this case, at C. Or imagine this was the number, imagine this is the point over 4 up to. Okay, this is the point 4, 2. So where is there a local maximum? At 4. What is that local maximum? It's 2. The y value is the what. Okay, what is that local maximum value? What is the high point? Right there of the graph. Okay, a local minimum is a low point. The graph's going down, it hits this low point, and it turns and goes up. So, where is there a local maximum? At this x value. What is the local, excuse me, I said maximum, I meant minimum. Where is there a local minimum? At this x value. What is the local minimum? Whatever this y value is, okay? This has a y value of 5, this has a y value of 4.5, 4.1, 4.01, and then all of a sudden 4. And then it turns and goes back up, 4.1, 4.2, 4.3. So that is what the local minimum would be 4. Okay? Now, on this bottom part in class, I gave 2 functions. I've got g of x, so that's this function, and then I've got f of x, that's this function down here. And then I asked all these questions about those 2 graphs. I had students break off into groups and try to answer these talking amongst themselves. I would like you to try to do that as well. Pause the video, see if you can answer these on your own, and then I will show you, when you get done, you can unpause the video, and I'll show you what the answers should have been, okay? So please pause the video now. All right, so hopefully you tried these. What are f of -1? So f of -1 is 1. So what is the y value when x is -1? So that'd be 1. The f value, when you plug in a 5, you'll also get a 1. That's this point. And for g, when you plug in a 0, you get a 5. So I was trying to make sure you were paying attention to which graph at what time. What is the domain and range of f? Well, f, if you look at the x values, or the width of the graph, it goes from -1 to 8. So that's my domain. And then my y values, my lowest point is -2 and my highest point is 4. So that's the range. For function g, it's from -1 to 7 is the domain. And then the range is from 1 to 5. Okay, from low y value to high y value. List the x and y intercepts. G just has a y-intercept at 0, 5. X has both an x and a y-intercept when it goes to the origin, and then it also has an x-intercept at 4. For what values of x does f of x equal 0? This is actually just another way of asking about the x-intercepts. When is your function 0? Well, that's when you're sitting on the x-axis. Okay, so 0 and 4, those are my x-intercepts. This is a kind of a trickier one. For what values of x is f of x greater than 0? So where is the function positive? And a lot of students will say, well, at -1 it's positive, and they'll say at 5 and at 6. Remember, you want to include everything. It's not just -1, it's also -3/4 and -0.5 and -0.1. Okay, everything from -1 to 0, including the -1 but not including 0. If we had or equal 0, we would include the 0, but we don't. So put a parenthesis. And then everything from 4 to 8, all those values are positive as well. Okay? At what x value does g of x have a local minimum? Here's my local minimum at 3. What is the local minimum? 1. At what value does x have a local maximum? Well, this is the point 0, 5. So at 0, and that maximum is 5. F of x has a local minimum at 2. That minimum value is -2. There is no maximum for f of x. And then these are your intervals where f is increasing, where f is decreasing from -1 to 2. And then g was increasing on 2 different intervals from -1 up to 0. And then it starts to decrease from 0 to 3. Then it starts increasing again from 3 to 6, and then it goes constant from 6 to 7. Okay? So, if you got those, take a look at your worksheet and let me know if you have any questions. Thank you.